Thank you. I've been listening to the talks all this morning, and they've been super good. They're kind of tough acts to follow. So my talk that I'm going to speak on today is titled Teaching GraphQL Lessons from a Beginner. Spoiler alert, I was the beginner. So to introduce myself again, my name is Leanne Shapton. I am a software developer here in Toronto. I work at Shopify, so my colleague Scott gave a talk earlier this morning. So if you haven't heard of Shopify, we are an e-commerce platform that allows you to sell products online. And like many other platforms, Shopify encourages third-party developers to build products and services on top of our platform for customized experiences. So to enable partners or developers to do this, we offer them tools. And two of these tools are our public GraphQL APIs. So Scott talked about one of them this morning being the storefront API. And we also have another public API called the admin API. So developers, third-party developers can use these GraphQL APIs and use GraphQL to build custom shopping experiences from a customer's perspective using our storefront API, or they could build custom merchant apps to make it easier for merchants to run their stores. For example, they could create a shipping or a fulfillment app, and they would use the admin API to do that. So I joined Shopify about 2 years ago, and actually the first team that I joined was our storefront GraphQL API. So this was before we had launched any of our GraphQL APIs publicly, but we were gearing up to launch this storefront API. So the task that I was given was to create example apps to demo to partners and third-party developers on how, or explain to them how they could use this new GraphQL API. So before joining Shopify, I had heard of GraphQL. At my previous company, we were contemplating whether to use it as part of our stack, but I had yet to build anything with it. So I started on the all too common path of which we're all very familiar as software developers about learning a new language. So my talk today is actually not very technical, but it talks about the path to learning and also teaching a new language. So if you read my description prior to me being up here, you were either interested in it because you yourself are a beginner and you want to learn GraphQL, or you may be a lead and are responsible for mentoring or teaching other members on your team about GraphQL so that they can start contributing to GraphQL projects at your company. So I'm going to take kind of a giant step back and look at how we learn new skills. I'm going to go over a model for learning new skills. And then out of this model, you'll see large differences between if you're a beginner in this model or if you're an expert. And the way that we tackle problems or even learn new information changes as we go through this journey. And then hopefully, if you are a beginner in the room today, you'll leave with some tools for learning or teaching GraphQL to the other members in your team. So let's start with this model for learning new skills. So there's a whole domain around educational research, and there's this model for skill acquisition called the Dreyfus model of skill acquisition, and it actually has 5 different stages, which says that everyone learning anything new will have to go through every single one of these stages. I first heard of this model. I was introduced to it actually at a programming workshop here in Toronto put on by Greg Wilson. It was called How to Teach Programming and Other Things, and he took this 5-stage model and actually simplified it into a 3-stage model, which I think really suits the purposes for today, so I'll use this simplified version. But what it says is that when you learn a new skill, you will always start as a beginner, and then you'll graduate to a competent practitioner, and then maybe or never eventually get up to the expert, which is the top of the skill acquisition model. So let's start down at a beginner. We've all been here before, even if we choose not to admit it, but we all start as a beginner, right? This is a difficult stage to be in because you don't know what you don't know. You lack a ton of context. You're often making mistakes. You feel stuck. And the reasons behind that is because you lack a mental model of the new domain. And you'll make false assumptions based on surface similarities. Because we don't know our new domain, we rely on other domains that we do know to fill in those gaps. And this is where we make mistakes. So I kind of like to use this example. GraphQL. You've never used GraphQL before, but you know about programming languages and you know about graphs. You may think GraphQL, and I've heard this before, and I don't think it's silly, that GraphQL is a programming language for making graphs. And this is like a mistake maybe a beginner would make because they lack the knowledge in this domain area and rely on the other domains that they do know. Another frustrating feeling for beginners is this feeling of being stuck, and you're kind of spinning your wheels. And this is because you're also lacking this context or mental model. So when you're learning new information in this domain, you have nowhere to store this information. So it makes remembering and retrieving that information later when you go to try to solve a problem very difficult. So beginners require step-by-step instructions because when they look at a problem in this new domain area, they don't know the steps to solving that problem just yet. But as you get context and more knowledge over time, you graduate from being a beginner up to a competent practitioner. And this is actually a really great level to be at because you now have this mental model that makes learning a lot more effective and efficient. Because you kind of know this domain space, so when you're learning new information, you can store it in the appropriate areas. You're no longer making those false assumptions. And then it makes, when you go to tackle a problem, remembering and retrieving that information you maybe learned last week so much easier. Also at this stage, we employ something called analytical decision making. So if you remember back in grade school where your teacher always made you to show your work, this is analytical decision making. So as a competent practitioner, because of our experience, we can look at a problem in a domain area and know what is important about that problem and the steps to solving it. And we will have a deliberate plan. We'll know what steps we need to take to solve that problem. This is different than an expert. So people may never get to that level of expert. It takes years or maybe even decades. And an expert actually thinks very differently and tackles a problem very differently because they no longer use analytical decision making. They are so good at this skill that they use intuitive decision making. So their mental model at this level has become so complex that the individual components of the model has faded back in memory, and when they go to solve a problem, it's intuitive. They may actually not know the exact steps that it takes to solve that problem because they're so well-versed in this new skill that it becomes second nature. So this is sometimes why another student is better at teaching another student about a problem than maybe a professor is, because the competent practitioner knows the individual steps, and it's a very deliberate plan to a solution than maybe an expert would have. So for today, we're not really concerned about being an expert because I heard in some book that it takes about 10,000 hours. We're really concerned about getting to this second level, being a competent practitioner. You can contribute competently to the projects at your company or building software. So we want to go from this really difficult phase of being a beginner, not knowing anything, making mistake after mistake, and really feeling stuck and spinning our wheels, to having this better mental model and really being able to solve most problems. So how do we do that? Let's identify the differences between being a beginner and a competent practitioner. The really big difference is knowledge and context. Knowledge takes time. It takes time to acquire that, but we can give beginners context. So context allows learners to remember and retrieve new information. So if we give context, maybe in a form of a mental model, when beginners are learning this new information for the first time, they'll be more efficient at learning it because they'll know where to store this information. So this is kind of where the next half of my talk will go in building a mental model, and particularly for GraphQL and APIs. So I've used this term a bunch. I think it's about time I define it. Mental models are conceptual frameworks consisting of generalizations and assumptions which we use to understand the working of things. Key points here, they're generalizations, and the whole purpose of them is just to help you understand. So all models are wrong, but sometimes they can be useful. So they don't have to be accurate, they're just helpful to being able to understand a domain. And it's okay to make generalizations. So when I was learning GraphQL, I made these own mental models for myself, but before giving this talk, I thought I probably should talk to other developers and hear about what their mental models are. So I interviewed a bunch of developers at Shopify. This was actually a couple years ago when we were launching the public GraphQL APIs for the first time. And so people were some people at Shopify had been using it for a couple of years, but more people were starting to starting to learn GraphQL. So I found out that some of the key ideas understood by beginners, particularly around APIs, was that most developers knew what the client-server basics are. They understood this sort of model. Most beginners or developers could list off what the CRUD operations were, HTTP methods, and RESTful APIs. So I'm going to build these mental models, but I'm going to start with these basics. Because you remember, as a beginner, beginners don't start with a blank slate. They already have these existing domain models, and what we want to do is establish similarities between our existing domain models and GraphQL, as well as highlight the differences so that you don't make those false assumptions. So what I've done here is to kind of simulate how the mind works. I've used light bulbs to identify key ideas, and then I've drawn pink arrows between those ideas that are related. So let's start with the example of a beginner's API model. We have this client that's over here. It's a user interface of some sort. It could be a web browser or a mobile device. And then our server is over there that has all the data. And we want to communicate with that server. And it's often over a network of some sort. In between our client and our server is our API interface. So we'll use the API to communicate with our server if we are the client. So common RESTful APIs, this was talked about earlier today, associates or organizes the server's data into resources. So there's one endpoint for each resource. I'm talking about like common RESTful APIs that we would think of. And then each of these endpoints, which would hold all a particular resource's information, would define CRUD operations. So that's create, read, update, and destroy. So an example, if a client wanted to get information through a RESTful API from the server, what we would do is send an HTTP GET request to a particular URL, because we want a particular resource and we want to read that resource. So the server knows to perform the read operation and fetch the resource data because of the HTTP method we use. This is, I think, a concept when I was talking to developers and even for myself that I think we either take for granted or not well understood, that the server knows what to do based on the client's HTTP method. And I point out this difference because this is not true for GraphQL. And then the server will respond, or the API service will respond with resource data in a format of some sort. So this slide just shows that how an HTTP method will map to a CRUD operation. So if I want to create something on my server, I'm going to use a post method and so forth. So now we have kind of a basic mental model that most developers may or may not hold for understanding APIs. We want to introduce these GraphQL specific concepts before adding GraphQL to our mental model. So some things that are unique to GraphQL is the graph. So the graph in GraphQL. We just saw that common RESTful APIs will organize a server's data by resource. Here, all of the server's data, or the app's data, is organized in a graph. So that means each node on the graph will represent an object type of that app, and the edges of the graph will represent the relationships. And this is where you get that one endpoint, because all of this app's data is organized in this one schema. Another couple unique concepts to GraphQL is object types and resolvers. So we heard about schemas. So to build this graph, this is all defined in a schema. So each one of those nodes outside of query is defined in your schema. And what query actually is, it's just out of the box with GraphQL. It's just another object type. But the ones that are specific to your app, you need to define. And you define that in your schema language. So you have a type shop, and it will have names and products. And this is why GraphQL is also a type system. Erica talked about this today, is that you're defining it here in your schema, and this will build and map directly to how your graph looks. And then also with our common RESTful APIs, we noticed that the server would know whether to fetch or modify data, or sorry, the API service could tell the server either to modify or get certain information based on CRUD operations. We don't define CRUD operations here. Instead, this logic is held in resolvers. So each object type is backed by a resolver and will tell the server what to do with the data. So now that we have these new concepts, we can add this on top of our mental model. So we still have the same structure where we have a client, and over there we have a server, and in between these two things we have our API services. A key point is that our GraphQL API can exist in parallel with our REST API. It's just another interface. So if the client wanted to communicate with the server through the GraphQL API, they would hit this interface. And we can see what's different from REST, or common REST APIs, and our GraphQL is that all of the data from the server is organized into this graph structure. And then we can see that there will be one endpoint. Now, we talked about distributed schemas earlier today, so you can see how you could add these more complex topics on top of this existing mental model. But this is a very simplified version. So let's go through an example as if I was the client and I wanted some information from my server through the GraphQL API. So as a client, I'm going to send an HTTP request, but I'm going to send a POST request. Scott mentioned earlier that GraphQL works with either GET or POST requests. That is true because there is no mapping between the action done by the server and the particular HTTP method. We use a POST request merely because it has a nice body to include the tree-like object structure that the client wants from the server. So the client dictates what fields that they want from the API service. And based on this structure, the API service knows how to traverse their data graph. So we'll start at query, and at each field or each node, we're going to execute the resolver. Because remember, each object type is backed by a resolver. So based on our client request, I know I'm going to start at query. This is the entry point to my data graph. And then I'm going to resolve that node, which returns resource 2, resolve that node, which returns attribute. And I will only traverse those nodes that the client tells me to. So only data requested by the client is fetched. And then what also is interesting and cool about GraphQL is the response you get back looks a lot like what the client requested, like the same sort of structure. And that is because when the API service is traversing the data graph, it is building up this JSON response. So when it hits the query, it's going to resolve that, and the the key in your JSON response will be the field name, and then the value will be whatever the resolver returns. And you always have to end with a scalar value because the leaves of the graph are all scalar. So yeah, this slide just shows that a server's JSON response mirrors the client request, and that's because how it resolves, how it traverses the data graph and resolves each object type. So we can read data from our GraphQL API, but we also want to mutate data. So I talked about the query object type being the entry point into a data graph. There's actually another one called the mutation type, and there's also other ones, but these are kind of out of the box object types that come with GraphQL are the entry points to your data graph. So if you want to mutate data on your server, you would extend the mutation object type with certain fields describing your mutation. So if I want to mutate resource 3, I add a field onto my mutation object type. I can send in some arguments, and then I need to tell, this is just another object type. So I also have to define what I'm returning, the type I'm returning, and the type I'm going to say I'm going to return this mutate resource 3 payload. I have to define that, and that will return resource 3. So it works the same way as we saw when we were querying our GraphQL API, except now our resolver holds more logic than just grabbing information from the database. It's also going to mutate data. So I send this HTTP POST request, and the only reason I'm using POST is because I have this nice body to send my client request in. And if we start at the top of that tree-like object, we know that we want to start at mutation. the field is update resource 3, so my API service is going to go resolve that. The server will mutate whatever that resolver's logic is, and then we're going to return the mutate resource 3 payload. And then the next thing is going to go grab resource 3 and then the attribute. So as it's traversing this data graph, it's going to build my JSON response that it's sending back to the client. So at this level, it resolves, remember this had my mutation field on it, so it's actually going to update the resource at this point, and then when it goes and returns this, the remaining object types, it's already been updated. And then it's going to build the response and send it back to the client. So I found these mental models extremely helpful when learning because it clarified some key differences between what I already knew about REST APIs and what was new about GraphQL. So kind of one of those things that feels uncomfortable at first is GraphQL has only one endpoint in a simplified version and organizes server data in a graph because we're so used to APIs to be structured around these resource types, which my team is actually struggling with right now because we're redesigning or we're building out what exists in a REST API in a GraphQL API and not having to follow those same design constraints is difficult. Also, what I found was kind of another aha moment was nodes represent objects and relationship between these objects are described by edges. So again, that's more detail around the graph. There's no mapping functions implemented on the server and the HTTP methods. That was kind of something I didn't realize. I didn't actually even put that together when about REST APIs. It wasn't until GraphQL that didn't use that I was like, oh, that's actually a thing. And then each object is backed by a resolver. So kind of the take-homes I hope you take from this talk is that if you are learning any new skill, is kind of understanding what you already know and what you don't know, and making connections of what's similar between what you don't know and what you do know, and then also what is different, so you don't make those false assumptions. And if you can help out anyone on your team learning a new skill, giving them the context will help them more effectively and efficiently learn a new language. If you found any of these diagrams that I showed today helpful, I have a Medium post about it. Feel free to grab that information from there. And thank you so much.